This video will conclude section 5.6 and chapter 5, and we will talk about how to use the least common denominator that you found in the previous video to add and subtract algebraic fractions. Now, to add or subtract fractions, we do the same thing that we learned before on adding fractions. Just because they're an algebraic fraction doesn't change anything. First thing we have to do is to find the least common denominator, because that's the only way we can add fractions. And then we are going to use that least common denominator to find an equivalent fraction. So we're going to multiply the top and bottom, the numerator and denominator, by the same number so that we can get the number we need in the denominator and thus change the numerator to match that. Once we've done that, we can then add or subtract the numerators all the way across and place that result over the least common denominator. And then, if possible, we want to, again, reduce back to lowest terms. So, for example, in number 61 here, we see that we've got 3a plus b quantity over 6 plus 5a over 12. And our least common denominator, in this case, we can see relatively quickly, is 12. So what we would need to do is we would need to multiply the 6 by a 2 to make it 12. So that means that we will also need to multiply the top by 2. And when we do that, we make sure that we distribute to each piece. So in this case, we end up with 6a plus 2b over 12 plus 5a over 12. And now that we have a common denominator, we can just add across and we can add like terms. So we have 6a plus 5a is going to be 11a. And then we've got 2b. And this is all over 12. Then we want to check to see, is there anything in common that we can factor out in the numerator? In this case, no, there is not. So this is as far as we can go to simplify. I don't want to see anybody trying to simplify this 2 and 12. Remember, you can only simplify when you've got multiplicative factors, not when you've got addition and subtraction of terms. So we're going to try another example here. We want to subtract, and in this case we've got 9, and again you can think of any whole number as a fraction being over 1. And in this case it's pretty easy, since one of the denominators is 1, that the least common denominator is going to be the other term. So in this case we know we need to multiply the 3y over 3y by our 9 over 1. And then our other piece, the 2x minus 1 over 3y. What we could do here in this step, which might actually be beneficial, is to turn this into addition by distributing that negative to the numerator. If we do so, if we want to make sure that we distribute that negative to both pieces, this would end up becoming a plus negative 2x plus 1 if we would change both of those signs. So now when we simplify, we've got another step taken care of. So in this case, we end up with 27y. That is not going to combine with pieces in the numerator of the second fraction. So we can just write those down, minus 2x plus 1. And then we've got over our common denominator of 3y. Again, there's nothing we can do to simplify this one because the numerator has no like terms. And this would be our final answer. So I would like you to pause the video at this point and try example 63. Note that you've got both subtraction and addition going on, and you need to find a common denominator for all three terms. So in this case, our least common denominator, which I have listed here, is 24, and all three terms need to be multiplied by something to get to 24 in the denominator. The first one needs to be multiplied by 4 to get 4 times 6 is 24. The second one needs 3 times 8 is 24. And the third one needs 2 times 12, which is 24. If you notice here, I distributed the 4 to each piece in the first fraction, so 16a minus 4b. In the second, I made sure to bring this negative sign here through when I multiplied by the 3. So this is now negative 3b and minus 9a. And then the 2 times 7 would be 14a. When we combine like terms, we have 16 minus 9a, which would be 7a. 7 plus 14 is 21a. And negative 4 and negative 6b is 10b. Common denominator is 24. Again, there's nothing in common in the numerator to factor out, so this is as far as it goes. We have a few more examples here. And one thing I want to point out, and we talked about this in the previous video, is that sometimes we need to be able to factor out a -1 to change the order of the terms. If you look here, x minus 4 and 4 minus x may look very similar, but there's one thing missing. They're not the exact same. The thing that is missing is that they are in the opposite order. And we can always change the order of this by multiplying by -1. So I'm going to do that for the second term here. I'm going to multiply by -1 over -1. So the first term, 8 over x minus 4 stays the same, plus -2 over, when I distribute that -1, I get -4 plus x. Then I can just rearrange the order because addition is commutative. So we end up with 8 over x minus 4 plus -2, and again I can change the order here, over x minus 4. So because I multiplied by that -1, I was then able to switch the order. That's the only thing we can do, is switch the order of the terms. And so now we have 8 minus 2 is 6 over x minus 4. Again, nothing can be simplified because there are no like terms between the numerator and the denominator, no like factors that can be removed. Sometimes we need to factor denominators, and we saw that in the last video as well. We have y squared minus 5y plus 6, y squared minus y minus 2 as our denominators. So if we wanted to factor this, these ones aren't too bad because they just have coefficients of 1. Factors then of 6 that are going to add to be -5. Now be careful here because you might be tempted to try 6 and 1. But if you were to do that, you would need two different signs, which would make that a -6. In this case, you are looking for -2 and -3, because those will multiply to give you a +6 and will add together to give you a -5. For this other denominator, again, we have y and y, factors of -2 that add to be -1. Well, this is just going to be -2 and +1. So if we wanted to find our least common denominator now, we have the common factor of y minus 2, and we only need that once because it only shows up once in each case. We don't need to write it down twice because it's a shared term. And then we have y plus 1 and y minus 3. And again, we only need to write them down once because they are only showing up once in each one of those denominators. If we look at the first fraction, we're missing a y plus 1. So we will multiply top and bottom by that. And the second fraction is a minus. I'm actually going to move that up here to the 3 because it's just going to be easier to distribute a -3 than to have the minus sign out front. And we have our y minus 2 in the denominator, our y plus 1 in the denominator, and then we need to multiply by y minus 3 over y minus 3. So again, if we distribute now, then we've got 4 times y, so 4y, and 4 times 1 is plus 4. And then over here, when we distribute that -3y, when we distribute that -3, we get -3y plus 9. Again, we have to make sure that we distribute it to both of those. And we have our common denominator of y plus 1, y minus 2, y minus 3. So if we combine our like terms, we have 4y minus 3y is y, 4 plus 9 is 13, and we have our common denominator y plus 1, y minus 2, y minus 3. And that is our final answer. We have a few more examples here. I want you to pause the video and try example 66. Again, make sure that you factor each of these denominators first and then see what like terms you have, and then from there take the remaining pieces. So for this example, you should have found that your least common denominator was 6x times the quantity x plus 2. Because when you factored everything out, yes, you had a 6, a 2, and a 3, which the least common denominator amongst those would be 6, and then you have an x and an x plus 2. So that gives you your least common denominator, 6x times the quantity x plus 2. And so the first term needs an x plus 2. The second term only needs a 3x because it already has the 2 and the x plus 2. And the third term just needs a 2x because it already has a 3 and the x plus 2. So in this case, when we distribute, we get x plus 2 for our first fraction, and then we get a minus 3x from our second fraction and a plus 2x from our third fraction. When we combine all the like terms, x minus 3x plus 2x is going to simplify to be 0, and we are just left with that 2 up top. Now we can reduce the numerator and the denominator because 2 divided by 6 is 1/3. So then we're left with 1 over 3x times the quantity x plus 2. And the one thing that I want to point out here is if you're having to put this in the computer in a homework system or in your calculator, you want to make sure that you are careful with your parentheses. This would be 1 divided by parentheses 3x parentheses x plus 2, and then we would close both sets of parentheses because we want to make sure that that whole denominator is included underneath the fraction bar. Another example here which requires a little bit of factoring. So if we can go through and factor these, we can use the AC method, we can use guess and check. I want you to pause the video here for a second just to factor those two denominators and see what you end up with for the least common denominator. So when you work through that one, you should have found that this first one factors to be 2x plus 5, 3x minus 7, which does look a whole lot like the numerator except for that minus sign. And the denominator here factors to be 2x plus 5, 3x plus 7. Again, very similar to the numerator here, but not exactly the same. And so now if we wanted to find our least common denominator, well, in common they have a 2x plus 5. Then we need those remaining terms, be 3x minus 7 and 3x plus 7. So if we go through, we know that our first fraction needs a 3x plus 7 because it's got the minus 7 already. And we need that in both the numerator and the denominator. And so that's going to be multiplied by our 3x plus 7 over our 2x plus 5, 3x minus 7. The second term is subtraction here. You have the option of bringing that up top if you want to. In this case, we need a 3x minus 7 over 3x minus 7. And we still have our 3x minus 7 that we started with times the denominator 2x plus 5, 3x plus 7. So now if we multiply things out, we've got 3x plus 7 times 3x plus 7, which would give us 9x squared plus 42x plus 49. And then we are subtracting off, and I'm going to put this in parentheses so that we don't forget to distribute that negative. We end up with 9x squared minus 42x plus 49. All over our common denominator, 3x plus 7, 3x minus 7, and 2x plus 5. And it doesn't matter which order I write these denominator pieces in. It's the same as the least common denominator. We don't have to worry about the order for these factors in the denominator because multiplication is commutative. Now this last step, again, we want to make sure that we distribute the negative to everything in this second half. So we have 9x minus 9. So we have 9x squared plus 42x plus 49. And if we distribute the negative, we've got minus 9x squared plus 42x and minus 49. Again, all over our least common denominator. Now the 9x squared minus 9x squared is going to be 0, and 49 minus 49 is going to be 0. And all we are going to be left with here, I'm going to kind of write it up here because we're running out of room, is we end up with 84x over our common denominator. We make sure that we write this all out. 3x plus 7, 3x minus 7, 2x plus 5. So that is our final answer for this problem. So we have two more examples here. One example, I want you to pause the video here, see if you can do example 68, and then resume the video to see if you've got the correct answer, and then we'll work the last problem together. Now for this example, you need to be careful. I know it might seem confusing with the second fraction having 2 minus x. We know we have to do something about that -1, but once we factor out that -1, we've got x minus 2, which is the same piece that we have in this first fraction. So the first fraction factored to be x plus 2, x minus 2, and then if we factor out that -1, we've got x minus 2 left, and then x plus 2. Now, -1 does not need to be part of the least common denominator, because anytime you've got a 1 or a -1, we can always just kind of bring this up front. Essentially now, this -1 is going to ultimately multiply by the negative out front and become positive. And we'll see how in our next step, the first fraction did not need anything. It had the common denominator. But if we bring that -1 up top, then we would have the negative times the -1, which will give us a positive here in the end. Then we need the second fraction to have x plus 2 over x plus 2, and the third fraction to have x minus 2 over x minus 2. Again, when you distribute and multiply everything out, you should have ended up with 2x plus 4x plus x squared plus 4 minus x squared plus 4x and minus 4. Again, making sure that we distribute the negative in the third fraction. In the second fraction, it multiplied by the -1 to become positive. And when all is said and done, we end up simply with 10x over x plus 2 times x minus 2. So, finally, our last example here, we're going to look at one that has a cubic now we have to factor. So if you were to factor that x cubed minus 1, and we learned in section 5.3 how to factor the difference of perfect cubes, this ends up being x and 1 are the cube roots for our individual pieces. Then we look here, we've got x squared, we multiply them together would be 1x, and then we square the 1. And we look at the signs then, we have the same as negative, the opposite is positive, and the last is always positive. Now if you look at the second denominator, you might try to want to factor that, but there are going to be no factors of 1 that are going to also add to be 1. And if you notice here, it's really just the same piece that we have when we factored the cubic. So in this case, our least common denominator is just that cubic. It's x minus 1 times x squared plus x plus 1. So all we need to do is multiply the second fraction by x minus 1. So the top fraction, the x squared minus 1, is going to stay as is. And then we're going to have an x squared plus x plus 1. And then we're going to add to that, we said we need an x minus 1 over x minus 1 for our second fraction, because that's what it's missing. We still have an x minus 1 over x squared plus x plus 1. And again, I don't want to see anybody tempted to try to cancel here, because if you cancel or you try to divide the x minus 1 by x minus 1, you end up with what you started. And the whole point of this is to end up with something a little more complicated, but so that we can get the common denominator. So in this case, we have our x squared minus 1 from our first fraction. When we multiply out for the second fraction, we end up with x squared minus 2x plus 1. And since it's plus, we don't really need the parentheses there. And then this is over x minus 1, x squared plus x plus 1. So now if we look, we've got x squared and x squared is 2x squared. We've got a minus 2x, and we have the plus 1 and minus 1 are going to subtract to be 0. So then this is over x minus 1 times the x squared plus x plus 1. And again, we need to make sure to check to see if our numerator does factor, and in this case it does. We have a 2x in common, And if we factor out that 2x, we are left with x minus 1 over our x minus 1 times x squared plus x plus 1. And now we can simplify the x minus 1s because everything's been added together. And we are left with a final answer of 2x over x squared plus x plus 1. Now it's possible in the first case, some of you might have noticed that x squared minus 1 does indeed factor to x plus 1, x minus 1, and you could have simplified that, and then you would have already had the common denominator of x squared plus x plus 1, and that's perfectly fine. You can go through, you would end up with the same answer of 2x over x squared plus x plus 1. So this concludes the video for 5.6, which is the last section from chapter 5. Please now go online and complete the homework for 5.6, and then once you've completed that, complete the quiz for the second half of chapter 5.